Okay? So 3.6, number 4, we're going to do it together. And then we're going to come back to that review sheet. And we're going to do these. And then we'll review some other things. Because obviously, these word problems are on the exam, but there's other things on the exam too. So, here we go. First thing we're going to do is read the problem, reading problem number 4. And we have got to figure out which formula we're going to use to do it. So, who has a thought on that? Problem number 4 in the homework, 3.6. What formula shall we use? I looked something, I couldn't make it out. Absolutely, future value. Why is it future value? Well, what am I doing? First of all, I'm making payments, aren't I? Right. So I make payments for 2 reasons. I'm either paying off a loan or I'm saving for the future. What am I doing in this problem? Saving for the future. Okay? This is going to be a free response question on the test, on the exam. No partial credit for the wrong formula. So you've got to figure out which formula you're going to use. Future value. I will give you the formulas, so you do not need to worry about that. I'll give you future and present value. We're doing future value. All right. So here we go. Your goal is to have $1 million. So where's that million go? That's what you want to have. How long will this take? Oops. If you make monthly deposits of $323. So my payment amount is $323. And the account is paying 0.045. I'm doing it monthly. How long will it take? Oh, that means I don't know the time, right? So what am I going to put up here for this exponent? Not just n. What's it got to be? It's got to be 12n. Remember, this is the total number of payments I'm making. I don't know how many years it is, but I know I'm making 12 a year. Right? So 12n. 12t, whatever letter you want to use. If n might be a little confusing, I think I use t. Over 0.045 divided by 12. Now, if your mind is still at lunch, or you're just thinking, oh my gosh, I want to get out of here, stop it, open up your mind, and make sure that you can put all the numbers in the right spots. Because having the right formula doesn't help you if you don't know how to use it. Am I going to need logarithms to solve this? Yeah, this is going to be a little more complicated because my variable is up here. Right? So what do you think the first thing I'm going to do is? I'm going to divide the 323. Now, that isn't going to go in evenly, so I don't care if you divide it in. Please don't round it off. It's going to be problematic, so I'm just going to leave it 1 million over 323. this is what we're solving for. So I can find that, but I can't find it until I get this by itself. So I've got to get rid of everything else. So I'm going to go ahead and take 1,000,000 and divide it by 323. So I don't need to write that number down. This is now on my calculator, right? Now what do I need to do? Keeping in mind I want to get the red by itself, what do I need to do? I need to multiply by this, don't I? Don't I need to move this over to here? So I'm going to take it times 0.045 divided by 12. So I just typed it on my calculator, 1,000,000 divided by 323, and now I'm multiplying this over to here. Okay? So now that's gone, right? So I want to get the red by itself, so there's one more thing I need to do. What do I need to do? Add 1. Just add 1, plus 1. Now, I'm leaving that on my calculator, but for purposes of being able to talk about it, I got like 12.60, blah, 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 right? Equal to 1 plus 0.045 over 12 to the 12t. Now, since I have this thing by itself, now I log both sides, right? And out in front is going to come that 12t, which means I will then be able to solve for it. So the log of that number on my calculator is 12t log 1 plus 0.045 over 12. Because this comes out front. Alright, so again, I don't want to write down a bunch of crap, get a bunch of round off the error. What do I need to do? I have on my calculator right now, what's here is the 12.6 number. So what do I need to do to the 12.6 number? No, I don't need to divide. I first have to do something to it. I need to take the log of it, right? I need to take the log of it. So I'm going to take the log of that answer. So now I've got this. So now I need to divide by the 12. So just divide it by 12 equals. Okay, so now this is gone because I divided by 12. And now don't I need to divide by this? So divided by log 1 plus 0.045 divided by 12. How long is it going to take? 56 years. 56.43 years. And that's a tough one to type in. Especially for those of you that think you need to write down every single step.
Can we also divide out the 0.045 and the 12, like, before we start?
As long as you're not rounding it off.
Okay.
If that's a finite decimal, absolutely.
Okay.
So her question was, can I rewrite what's in red here? Can I rewrite that? And it's a finite decimal. So she said, I really don't want to have this. I would rather write 1.00375. Totally fine, because that's not rounded off. As long as you're not rounding off, you can write down anything you want. But that round off error will add up to some mistakes. All right. Okay, so that takes care of that. So Patrick, you got it? Okay. All right. let's go back to our review sheet then. And let's finish up these word problems and then look at a few other things too. So I'm gonna go ahead and erase this. We're gonna start with problem B. We already decided what formula we were gonna use. So here we go. What goes where for problem B? 5,000 equals 100. Easy, don't put anything in for E, easy. R3 or 3R, however you want to do it, yep. That's it. You gonna need logarithms? Yep, we are, because our variable is the exponent. Because this exponent has an E, I'll probably ln, but not yet. What do I have to do first? Divide by 100. So that is nice. You can leave it 5,000 over 100 if you want, but since it equals 50, that we'll just do that. Now we'll ln both sides. What happens here? ln. So 3R equals ln 50. That was easy compared to the last one. What'd you come up with? 1.304. Now we're going to do problem C. We're not going to do all these problems. We're going to do problem C. What formula did we say we were going to use? I erased it. Regular compound growth. I'm saving for the future. Why aren't I using future value? No payments. Exactly. No payments. All right, so what goes where? A, what's A? 765. What's P? 321. That's a 1. Don't do anything to it. What's R? I don't know, do I? So, what's N? 12. And how many years? So I'm going to go ahead and make this 60. 12 times 5. Now, am I going to need logarithms? No, I am not. When do I need logarithms? When my variable is an exponent. Don't be messing around with logarithms unless your variable is up here. Alright, so what's step 1 going to be? Divide in. I bet it doesn't go evenly, so I'm just going to leave it as a fraction. Uh-oh. What do I do now? I heard someone say something. Okay now. What? You're gonna take the 60th root of both sides. That's exactly right, Abby. You're gonna take the 60th root of both sides. Because isn't that the only way to get rid of that power? So 1 plus r over 12 equals the 60th root of 765 over 321. Remember that if you don't remember how to do the 60th root, you can always raise to the 1/60th power. Taking the 60th root is the same as raising to the 1/60th power. That 1/60 will need to be in parentheses. So, I'm going to figure out what this is, and so will you. Okay, so did you get 1.0145? I'm talking about just for the 60th root. All right, so you have figured out what the 60th root is. So now you have this number sitting on your calculator. What do you need to do to that number to get R by itself? Oh, I think first I would subtract 1. And then times by 12. What interest rate's necessary? 0.1749 or about 17.49%. Good job, Abby Co. All right. E, the current credit card balance on a student's account. Okay, what did we say we were going to do with this one, present value? Because we're paying off the loan. So let me get my formula up here. Credit card balance is 12345. Where does that number go? That's this. Isn't that the value of the loan? That's the present value of the loan. 12345. What the payments are, but I know the interest rate is an exorbitant 0.1899 divided by 12 because I'm making monthly payments, right? Monthly payments. And how many am I making? 72. 6 years. Okay, everybody got all those numbers in the right spots? You gonna need logarithms? No, it's gonna be an easy one. We're gonna get this thing typed in. And then we're just going to take 1, 2, 3, 4, 5 divided by that. All right. So again, you do whatever you're comfortable with. I'm going to type in the numerator here. 1 minus parentheses 1 plus 0.1899 divided by 12 parentheses raised to the negative 72. And then if we make a mistake on these, it's usually when we get all that nicely typed in, but we forget when we divide that this has got to be in parentheses. So divided by parentheses. So I don't know where you're at. For my bracket, I got 42 point something. So now I'm going to take 1, 2, 3, 4, 5 and divide it by that answer, that bracket answer. and I got 288.51. Would you agree with that? All right, so what would be the amount of each payment? $288.51. What will be the total of all the payments? Well, how many is he making? 72. So I'm going to take 288.51 times 72, and he's going to have to pay $20,772.72. That's a lot. I want you to think about that for a minute, guys. How much did he borrow on the stupid credit card? $12,000? How much is he ultimately paying? $20,000. That's a lot, right? Don't you? If you use your credit card, pay it off. Pay it off. Please, pay it off. All right, that's enough word problems for now. We can do more next time if you want. Let's look at the sheet, the same sheet that we've just been looking at. And let's look at a couple other problems on here. So let's look at part 3. I have the distinct advantage of knowing what problems are on your exam. So I maybe can narrow down our focus a little bit. So let's look at problem 3. Let's do some of these. Make sure we remember how all this other stuff works. So who's got an idea for 3A? This is a no calculator problem. Obviously the word problems are all calculator. So the exam's in 2 parts. You're used to that. Hollis?
Start by combining.
Start by combining. You've got to combine these 2. Kids, you can't solve a logarithmic equation if it's got 2 logs on the same side. Okay? So put them together. How do we put these 2 together? Multiply. So this is going to be 5x minus 10. Remember, when you put them together, they come, if they're added, they come together as a multiply. Now what do? We're down to 1 logarithm. What do? Loop-de-loop. So 4 to the second equals 5x minus 10. So 16 equals 5x minus 10. I got 26/5. That needs to ring some bells. Does that ring some bells? All right, let's look at the last problem in that section. Let's look at F. Well, this one's got even more logarithms in it. But again, you've got to combine. These 2 have got to be combined. So how are they going to go together? This is going to say what? ln what? X minus 2 over x plus 1. You're exactly right. Now, that problem is different than this one. This one, after I did my combining, I ended up with a logarithm on just one side. There was no logarithm over here. So I loop-de-loop. That's how I take care of it if I only have one. I loop-de-loop it. That gets rid of it. There's no loop-de-looping going to happen here, folks. This is even easier. Because if ln this equals ln this, don't those things have to equal each other?
Yes.
So x minus 2 over x plus 1 equals 6. X minus 2 equals 6x plus 6. 5x equals negative 8. I got negative 8/5. Did I do that right? That's bad news. Because if I put negative 8/5 back into my original problem, would this guy be a negative quantity? And can I logarithm, ln or otherwise, can I logarithm a negative quantity? No. So we're gonna throw that out. We did all that work and there's no answer. Okay, big difference. This kind of problem versus this kind of problem. They started the same way. We combined. If there's only one log, you're going to loop-de-loop. If there's logs on both sides, you're going to drop them out. But do not drop them out right here. Oh my gosh. Do not say x minus 2 minus x plus 1 equals 6. No, no, no. You can't do anything until you combine the logarithms. Okay. Next, number 4. 4a is a no calculator problem. So those of you lazy bums that normally just type that in, forget it. You're going to have to know what 4 to the 3 halves means. What does 4 to the 3 halves mean? Square root of 4 cubed. So this is the square root of 4 cubed. Well, what's the square root of 4? 2 cubed is 8. Easy. If you understand fractional exponents, which are radicals, it's easy. Negative 27 to the 2/3. What does that mean? Cube root of negative 27 squared. So what's the cube root of negative 27? Negative 3. Boys and girls, we can cube root negatives, right? We can cube root negatives. Can't square root them. But the cube root of negative 27 is negative 3. But then when I square that, I get positive 9. All right, that's all we have time for today. Let me hand you out some review materials here.